Network Appliance NS0-521 exam practice questions with explanations are available in the video for you to study. A storage administrator is deploying a NetApp ONTAP AFF system to support both NVMe, TCP and iSCSI protocols. Before hosts can connect to the SAN, which configuration step must be completed on the ONTAP system? A. Configure CHAP authentication. B. Configure DHH-MAC CHAP authentication. C. Configure logical interfaces, LIFs. D. Configure IPsec. The answer is C. In ONTAP SAN environments, LIFs, logical interfaces, are essential network endpoints that enable host connectivity for iSCSI and NVMe, TCP traffic. Each SAN protocol requires data LIFs on the appropriate SVM, storage virtual machine, for target access. Authentication methods like CHAP are optional, while IPsec is not required for standard SAN connectivity. An administrator is planning an NVMe, TCP network in a NetApp ONTAP environment. To improve performance and manageability, the administrator decides to segment traffic using VLANs. Which two benefits does VLAN implementation provide in this configuration? Choose 2. A. Increased resiliency. B. Reduced number of broadcast domains. C. Increased security. D. Reduced number of IP spaces. The answer is B. C. Using VLANs in an ONTAP NVMe, TCP configuration isolates network traffic into separate logical segments. This reduces broadcast domains, improving efficiency and minimizing unnecessary traffic. Increases security by isolating SAN traffic from other network types. Resiliency depends on network design, e.g., multipathing, and IP spaces are used for tenant isolation, not reduced by VLANs. A customer is deploying an NVMe protocol-based SAN solution using NetApp ONTAP. To define and manage which hosts can access specific namespaces, what ONTAP object should be configured? A. iGroup. B. Namespace. C. Subsystem. D. LUN. The answer is C. In NVMe over Fabrics, NVMe of configurations, ONTAP uses subsystems to control host access. A subsystem defines a list of NVMe hosts, identified by NQNs, and the namespaces they can access, similar to how iGroups are used for iSCSI or FC LUNs. Subsystem right pointing arrow NVMe equivalent of an iGroup. Namespace right pointing arrow NVMe equivalent of a LUN. During an iSCSI deployment, a customer plans to replace the existing twin-ax cables on a NetApp ONTAP cluster with fiber optic cables. To ensure compatibility, which two NetApp tools should the administrator use to verify supported port speeds and transceivers? Choose 2. A. Hardware Universe to determine supported transceivers. B. Interoperability Matrix Tool, IMT, to determine supported transceivers. C. Hardware Universe to determine supported port speeds. D. Interoperability Matrix Tool, IMT, to determine supported port speeds? The answer is AC. The NetApp Hardware Universe, HWU, is the primary resource for checking hardware specifications, including supported adapters, port speeds, and transceiver types for each ONTAP platform. The Interoperability Matrix tool, IMT, is used to validate software-level compatibility, such as OS, protocol, and host connectivity, not hardware specs like transceivers or speed capabilities. An administrator manages a NetApp AFF cluster with 2 SVMs serving LUNs. SnapMirror Active Sync has been configured, and a disaster recovery test is scheduled for the weekend. Which ONTAP command should the administrator use to verify the status of the failover test? A. SnapMirror Failover Show. B. Network Interface Failover Groups Show. C. Storage Failover HW Assist Show. D. SnapMirror Config Replication Status Show. The answer is A. The SnapMirror Failover Show command displays the status of SnapMirror active sync relationships, including whether a failover or test failover is in progress and the current replication state between the source and destination SVMs. Option B shows leaf failover groups, unrelated to SnapMirror. Option C is for hardware assist between nodes. Option D is not a valid ONTAP command. An administrator is deploying an NVMe over Fiber Channel, NVMe, FC, configuration in a NetApp ONTAP environment. Which switch setting must be enabled on the Fiber Channel fabric to support NVMe, FC connectivity? A. Create multiple initiator zones and multiple target zones. B. Configure iGroup and IQN mapping. C. Enable NPV on all fabric switches. D. Enable NPIV on all fabric switches. The answer is D. NVMe, FC relies on NPIV, N_port ID virtualization, to allow multiple virtual N_port IDs on a single physical fiber channel port. This enables multiple initiators and targets to share the same physical connection, essential for NVMe, FC operation. Option A. Zoning is still required but not unique to NVMe, FC. Option B. Applies to iSCSI, FC, using IQNs and iGroups, not NVMe. Option C. NPV, N_port virtualizer, is a fabric role mode, not required for ONTAP NVMe, FC. After completing an iSCSI configuration in a VMware environment, a storage administrator needs to verify that jumbo frames are supported end-to-end across the network path. What should the administrator do to confirm jumbo frame configuration? A. Ping from the host with fragmentation. B. Check the VM kernel adapter settings. C. Ping from the host without fragmentation. D. Check the broadcast domain settings. The answer is C. To validate jumbo frame, MTU 9000, support across the full iSCSI network path. Perform a ping test using a large packet size with the Don't Fragment, DF, bit set. This ensures packets traverse all switches, NICs, and interfaces at the configured MTU. If the ping succeeds, jumbo frames are properly configured end-to-end. Option A, with fragmentation, defeats the purpose of testing jumbo frames. Option B and D, checking settings helps but doesn't confirm end-to-end functionality. An administrator has deployed a new NetApp ONTAP system in a SAN environment. The customer wants to verify that ALUA, asymmetric logical unit access, is functioning correctly by observing changes in path states between active, optimized and active, non-optimized. Which action would trigger ALUA to change these path states? A. Shut down all FCLIFs on the HA partner node. B. Move the containing volume to the HA partner node. C. Shut down one FC leaf. D. Disconnect one FC cable on the node hosting the LUN. The answer is B. In an ONTAP SAN environment, ALUA determines the optimal data path to a LUN based on which controller owns the volume that contains it. When the volume is moved, or ownership changes, to the HA partner node, ONTAP updates path states. Paths to the new owner become active, optimized. Paths to the old owner become active, non-optimized. This demonstrates that ALUA is dynamically adjusting to reflect optimal access paths. Option A, C, D involve link or leaf failures but do not cause a change in ALUA path optimization state. They only affect availability, not ownership. An engineer is planning to migrate data from multiple third-party SAN arrays to a NetApp ONTAP system using foreign LUN Import, FLI. To perform the migration successfully, which configuration must exist on the destination ONTAP cluster? A. A valid SnapMirror license. B. At least one FC port in initiator mode. C. A valid NetApp XCP license. D. At least one FC port in target mode. The answer is B. In a foreign LUN import, FLI, migration, the destination ONTAP system must connect to the source, foreign, storage array as an initiator to read data from the source LUNs. The ONTAP FC ports must therefore be configured in initiator mode, allowing ONTAP to discover and import data from the external array. Target mode ports are used for host access, not for FLI operations. SnapMirror and XCP licenses are unrelated to FLI migrations. A customer wants to configure SnapMirror active sync between two NetApp ONTAP clusters across separate data centers using Fiber Channel, FC. What type of connectivity is required between the clusters to support this configuration? A. Dedicated FC switches and ISL. B. Shared FC switches. C. Cluster peering. D. Dedicated IP switches and ISL. The answer is C. To enable SnapMirror active sync between two ONTAP clusters, the clusters must first be peered. Cluster peering establishes trust and enables replication relationships, regardless of the underlying transport, FC, iSCSI, or IP. Option A and B. FC connectivity is required for storage traffic but does not replace cluster peering, which is a logical configuration. Option D. Dedicated IP switches and ISL are relevant for IP-based replication, NVMe, TCP or iSCSI, not FC.